Hello everyone, welcome to Calculus 3. Actually, we are still in section 5.2 about double integrals over a general region. Remember, there are type 1, type 2s, and indeed, if you look at the drawing here, I can recognize, according to the arrangement, according to the indication of the arrows here, I can say this is a type 1 region, right? Type 1 region, it is bounded by two vertical lines and a single curve at the bottom, single curve on the top. Type 1 region. And indeed, according to for this same region, according to the arrow here, it also can be considered type 2 region. In general, type 2 region, it is bounded by two horizontal lines, so it does fit. And the single curve to the left, single curve to the right, it still fits. So this same region can be considered type 1, type 2. And indeed, I'll say practically it may not happen a lot, but anyway, for class purpose, many times it will. We are going to have to handle a situation like that. Okay, type 1, type 2 regions. And then according to type 1, we have the way to evaluate a double integral. It is the integration with respect to y first, then x. According to type 2, it is the integration with respect to x first, then y. Okay, so this is the example I took from textbook again, example 5.15. Basically, we want to evaluate this double integral. And you could start as given, okay? You certainly want to give a try, even though it may look very simple, but anyway, you want to be aware, well, this x times e to the x squared is constant. So basically the antiderivative, it is whatever this part is times y. And then you're going to plug in this 2 minus x squared for y. Or roughly, I'm saying it will be in the fashion of x cubed times e to the x squared. I certainly believe the integral can be done using substitution and the integration by parts. I think I'm very likely that's both, but both integration by parts. Okay. And but as I just said, well, in this given fashion, basically the region we are considering here, it is type 1 in this given fashion. But according to our discussion, this same region also can be considered as type 2, right? So this is my description for the same region as type 2. And make sure you really can follow how the conversion happens. And I want to say mostly I do my conversion from the graph. If you have any other way, you got to tell me. I mean, for the homework submission part, even though some problems may not ask you the graph, but anyway, the graph, it is part of the answer. Okay, you do need to show the graph. So I understand that the same region can be considered type 2. And then somewhat using type 2 region, this same integral can be arranged using type 2 region in a slightly, well, I guess I cannot say slightly, it's just in a totally different way. Even though mostly they may look about the same, but anyway, it's really totally different. And then issue here is, when I look at the inner integral, this part of the inner integral, and certainly you are going to know the antiderivatives or integrals very well. I know this inner integral can be done very quickly using integration by substitution. It's all about x. And also, I need to replace x with 0 as for the lower bound. I suppose that's not an issue. And also, square root part, in general, it is a trouble. But anyway, keep in mind, we do have e to the x squared from integral. So when x is replaced with square root, the power of 2 will cancel the square root, right? So somewhat it can be handled in an easy way if you know integrals and antiderivative very well. And indeed, it is just true. I have no more x squared. I have no more square root to this moment. Okay. And then we still have the outer integral, that's for y. I keep this y outside, antiderivative e to 2 minus y, still takes integration by substitution, so you see this minus sign here. Antiderivative 1, which is just y. And then for the final round of evaluation, replace y with 2 and replace y with 0. This is number I took from the textbook. I believe it should be fine. If you see anything, if you have any questions, let me know. So I really think that's all about it, about section 5.2. We are working with double integrals. We are working with double integrals over type 1 region, type 2 region. Make sure you know the arrangement for each. Okay, how to evaluate double integral as an iterated integral in type 1, iterated integral in type 2, and also some things beyond that. You may want to know many times that we may have a region can be considered type 1 and type 2. And also the last example I just finished. We'll talk about this other example just in a moment. The last example I just finished. I'm saying sometimes you may have a given integral, iterated integral. Everything is given. Looks like we don't have to do anything else at all, just do a straightforward calculation. But there are tricks. Like in this case, if you could switch the order of integration, changing the order of integration, it does make the calculation a lot easier. And also I want you to know, sometimes you really will have to switch the order of integration. Otherwise, it may not give you the answer. And there's another trick worth to mention, type 1, type 2 regions. Okay, like the other example we did, this region really cannot identify it as single type 1 or type 2. And indeed, it is considered into 3 subregions, the so-called D1, D2, D3. Besides, they are not of the same type. D1 is considered type 1, then D2 and D3 both considered type 2. And accordingly, the integral over the entire region, it is the sum of the integrals over each part of the region. And then you will have to do calculation for each part accordingly. Section 5.2, double integrals over type 1 and type 2 regions. Thank you for watching.